welcome you all for the session. So I am from Vivekananda College of Engineering for Women from Department of Computer Science and Engineering. So today I am going to give a lecture about operating systems introduction. So myself E.Sowmya, Assistant Professor in the Department of Computer Science. So today I am going to give a lecture about operating systems, very basic introduction. So the syllabus which we have framed as a 5 units is from Unit 1 is of introduction, Unit 2 is of CPU scheduling and process synchronization, Unit 3 is from deadlock and storage management, Unit 4 is for memory and I/O systems, and Unit 5 is for file systems. So in this, from first unit, we are going to discuss about all basic introductions of operating systems and how the operating system and hardware are working together, what is the organization of a computer system, what is the architecture of a computer system, which all we are going to discuss about in this session. So our first unit, content of the syllabus is, so from Unit 1, as I told you earlier, is an introduction. So introduction of operating system and operating systems operations and what are the resource management techniques we are using in an operating system. And next one is operating system structures. In an operating system structures, we are going to discuss about system calls, system services, linkers and loaders, and the next segment is processes. So in this processes, we are going to discuss about its concept, process scheduling, operations of a process, and how the inter-process communications are communicating. So these are all the content of the syllabus which we are going to see in the introduction part of an operating system in the first unit. So now we are going into the concept called introduction of an operating system. So first of all, we should know what is operating system, right? So as we all know, operating system is one of the software. As a software, that software should manage all the computer hardwares. How this is going to be possible? So as of what is operating system is, an operating system is a software that manages a computer's hardware. This is going to handle the applications for user point of view as well as the system point of view. So this operating system is going to be an agent, is going to be work as a kernel program to make the computer and the user to make the communication easy. So this is the basic concept of an operating system. So next, where do we use this all operating systems in a day-to-day life? We are going we are in the hybrid life. We are using more applications for household activities or for cars, even for home appliances we are using a technology, right? So it may be manually controlled or it may be automatically controlled. So in this operating system, we are using everywhere, in each and every part of our appliances like cars, home appliances. It may also include from the Internet of Things, that device to communicate like smartphones, personal computers, enterprises computers, even in a cloud computing environment. So in every area, in every location, in each and every technology, we are in need of different operating systems. So the next is, what is the role of a hardware in an operating system? So in a previous slide, we have discussed about operating system. So what is the software is going to do in a hardware? Now, what the hardware is going to do with the operating system? So here, hardware is nothing but, as you all know, so hardware is just a physical component. It's going to be a physical component like TV, AC, fridge, washing machine, whatever it may be, like laptop, PCs. So how this is going to communicate with the input which we are giving and how it's going to deliver an output, right? So this should be handled by the operating system. So this computer hardware will give you a space, right? Give you the resources that you can accomplish, right? So what are the programs you want, what are the softwares you need to enroll or you have to fix it, that should be in need of the storage capacities that are all available only in the hardware. So as here, so hardware is a physical component that gives a platform to a software to install and fix it properly, and then it going to run each and every functions. So the second point, yes, as I told you earlier, so system like PC, it's not just one system, it has different components that include CPU, memory, I/O devices as well as the storages. So next, it has the fundamental responsibility to allocate the resources for different possible functioning of our programs. So next is what operating system do in a computer hardware. So as in a role of a computer operating system, the computer systems can be divided roughly into 4 types. One is of hardware, next one is of operating system, next one is application programming and a user. So the last end is the user point, right? So see this diagram, in this diagram, so we have roughly divided into 4 components like user, application program, operating system and computer hardware. So this, they should be concerned about from last to first. First is computer hardware, which is the possibility of having CPU, memory, I/O devices like mouse, keyboard, etc. All are considered as a computer hardware. So there, to make all the resources to be utilized by the help of operating system, which is going to run always as a kernel program, and by using this operating system, we can able to adopt different set of compilers, web browsers and different development kits like Spider. Nowadays we are using Python. So to install the Spider, the Python applications, you need a support of an operating system. This operating system should have the capacity to accomplish all the different application programs that you are installing, right? This application program is fully dependent on the user, because as a computer or a laptop or a mobile phone, the user need should be satisfied. So to satisfy the user need, the user may or might use different set of application programs, that each and every different software should be accomplished with this operating system. So there are different operating systems that have different capacities. So next one is, what is the most for, we have to understand what is operating system, what is a computer system, how it is going to combine work. In this, for this more understanding, we are dividing it into 2 concepts. One is from user view and another is from system view. So as of in a user view, so there is when to next explore to the next, we have different viewpoints. One is of user and system. I told you, right? So now from user view. So as a user, in the previous days, they will sit in a PC, right? Personal computer like a monitor, CPU, keyboard, mouse. That is only for an individual user with individual resources allocating by, that is called as a monopolize, right? User to monopolize its resources. That is designed for one particular user. So this, what nowadays we are doing, this is going to be maximized. See, now we are easy to use, now we are ease of use and some attention we are paying for the performance and the security, but we are not paying for the resources which we are using as a hardware components or a memory, because it's defaultly given in the system. So nowadays the PCs are converted into smartphones, tablets, even in a more advanced we are using a touch screen, voice recognition. Each and everything should be adopted with that operating system. So next one is system view. In the system view, we have the operating system is directly involved with the hardware. The program is more intimately involved with the hardware. So in the here that hardware need to wait for the resource allocation. That resource allocation will be made by the operating system. So here this computer system have many resources like CPU time, memory space, storage space, I/O devices. This hardware component need to handle with all these problems and need to solve all those problems, right? So as type of problems need to solve simultaneously. For this we are using different techniques, as I told you, process scheduling, CPU scheduling, everything will become under this problem solving method. So next is this going to be operating system is going to be act as a manager for allocating the resources, right? So next thing is, why we are made everything explaining only the general concepts like what is hardware, what is software, how it's going to react with it, how they're going to bind the software and hardware is going to bind each other, in which different point of view we have to see the computer and a system. So now let's off direct concept of a definition. So its definition is in concern. So operating system is the one program run every day, every time in a computer. It's called as a kernel. It will run in a backend for continuously without there is no stop. So it will run along with the kernel. There are two types of programs how to adopt, right? So first one is system program and another one is application program. This may not be necessary part of a kernel, but in the user point of view, this two also have to be adopted with the equalizely run with the kernel. So the next one is that is improper definition for a computer system. So now what we are going to see in a definition of words is mobile operating system. Because nowadays most of the people are not sitting in a laptop or a computer and working for a long time, right? So they are having the most compatible thing called mobile, right? That mobile also has some operating systems, right? So that operating system should include not only a core kernel, but there is no only core kernel is working on it, but also called as a middleware. This middleware is what? Mobile operating system. It's a set of software frameworks gives some additional services to the application developers. So next, for example, we have more number of operating systems, right? Like the two most prominently two OS. One is Apple iOS and another one is Google Android. It has more features and more adaptable things. More features can be adopted in a Google Androids. So next one is what is the organization of a computer system? How we are going to organize, right? What is organize now? See, in a modern general purpose computer system, it consists of CPUs and more number of devices to control, like USBs. We are giving more inputs, right? Like we are giving an audio jack, video jack, and whatever the things like Xerox machines, whatever the need as the input, there are more possibilities to give inputs. So, how to connect with the common bus? Because in a system, the multiple hardwares only combine with a single serial bus, right? So how is going to commonly connect with it and how to give an access between components and the shared memory, right? So this can be controlled by the two things in an operating system, have a device driver and device controller, right? So this CPU starts run and the device controller can execute it parallelly and compute the memory cycles. So this is one of the organizing architecture. See, first one is CPU, next one is this controller, so next one is USB controller, next one is graphics adapter, which are all connected with the hardware components like this, mouse, keyboard, printer and monitor. So this everything is connected only through one system bus to the memory. So this all are responsible with a single system bus to allocate all the resources from the memory, right? Because this each components may execute multiple instruction sets parallel, right? So each and everything need to be parallelly executed with one single bus to the memory. So next one is interrupts. Right, in a system or in a computer system organization, so interrupts is typically a computer operation. While the one input and output operation is performing, it's the device driver loads the information or loads the instruction to the appropriate register in the device controller. Then that device controller will determine what action to be taken. Right? After it starts the transferring of data from the device to the local buffer, once the action has been completed, the device controller informs the device driver that the operation has been finished and give the status as the device driver will return the status to write completed successfully or write device is busy. These two inputs, what if it is completed, it will give it as a success notification. If it is busy, it will give it as device busy the device driver returns the status, then how the controller will inform the device driver is on busy or it finished its work, because this all will be accomplished the different interrupt handlers. Okay, different interrupt handlers. So while the implementation of each thing, the CPU hardware has a wire connection that is called as interrupt request line. So based on that interrupt request line, the CPU will sense for executing each and every instruction and then reach for the number of interrupts to be done and jump to the next thing is called as interrupt handler routine. Right? It will move on to the next line. So that is called as interrupt handler routine. So in general, interrupt, we can say that device driver raises an interrupt by asserting a signal, and the interrupt request line will CPU will catch the interrupt and dispatch to the handler, which is interrupt handler. So this clears the interrupt servicing devices. So that can be accomplished by the device controller. So this is one of the simple example for the communication about the interrupt request line and interrupt handler. So as the device initiates and input and output devices, it will check for the execution. If the interrupt, it initializes the input and output, then it move on to the ready state, or if it does have any errors, it will generate an interrupt signal and then move on to the receiving or to the CPU to receive the transferring of a data, and then interrupt handler will process that data and return to the interrupter. If it does have any error, again the CPU will resume the work and again it will go on to the CPU device drive. So this action will take continuously, it will repeat it from both input from CPU and the I/O controller. So next one is, in the modern operating system, how we need more different sophisticated interrupt handling features. So why we need different handling? Because we need an ability to differ, because the same interruption will not be generated continuously. We need to have to overcome all different types of interruptions. So for that, we are in need of ability to differ the interrupt handling during the critical processing. So next one is the efficient way to dispatch the proper interrupt handler for devices. So next thing, we are going to deal with multiple number of programmings and multiple tasks in a parallel base with high priority and a low priority. So first of all, we need an interruption handler based on the priorities between higher and lower priority, and then it should be respond for the appropriate degree of an urgency. It depends on the emergency of a data to be produced or generated output. So it should be based on that, right? So based on that, the interruption handler should be indeed. So next, in this interrupt request line, we have two lines. One is of non-maskable interrupt and another one is maskable interrupt. In a non-maskable interrupt, this already reserve the events which cannot be recovered, right? The error which is arising, it cannot be recovered. But maskable is the CPU will power off, will switch off the CPU before the execution of a critical problems. So next one is storage structure. So in a storage structure, so first in a storage, if you are giving an input or that we consider as an instruction, first it will load. The CPU will load the instruction, then it will first load into the memory, then it will start to execute or rewrite the instruction in the memory, that is called as a main memory. So that is called as RAM. Okay. In a second thing, the main memory commonly implemented in a semiconductor technology. If we going with the semiconductor technology, so that memory is called as dynamic random access memory. It's called as dynamic random access memory. So in example for a memory, when you are starting a program, right? When you are putting first of all you are starting to run a program, that program is called to power on, that is called as a bootstrap program. While you are switching on the computer, it's booting, right? So that program is called as bootstrap program. So next one is RAM. RAM is more volatile because whenever you are powering off the system, it will lose all the contents, right? Next one is electrically erasable programmable read-only memory. It's called as EEPROM. Another form of firmware. It's another form of firmware. It's frequently write and it is a non-volatile memory. So in this we have two things. One is of instruction execution cycle, which execute on a system with what Newman architecture. First fetches an instruction from a memory and stores that instruction into the instruction register, and then it will arrange. Okay, it will arrange, and it is not mostly possible for when we go for this Newman architecture. It's always not possible for most of the system for the two reasons. One is of main memory because it usually stores very small amount of data, right? So next one is it's mentioned as volatile, right? It loses the content if it is turned off. So we won't go for non-human because of these two reasons. So here, before going into this, we can see the architecture, right? So this was explained in the previous slides. So we are dividing into three concepts. One is of primary storage, secondary storage, and tertiary storage. The secondary storage is always lower, right? If you go with the secondary storage, it was non-volatile storage. So next is, it will be primary storage, it will act faster, and it is called as the volatile storage. What does it consist of? What is the larger and smaller? So magnetic tapes, optimal disk, this is all the tertiary storage which will act as a storage, which we have used in the most previous, traditionally we have used. So next one is secondary storage, which we have seen now. Hard disk drives and non-volatile memories. It's called as a non-volatile storage. It's little bit faster than compared to the tertiary storage. So next one is main memory, cache and register. It's going to act as a primary storage, but the accessing time of this volatile storage is very fast, right? So these are the computer system organizations that was explained here. That was explained here in this slides. We see here. We have seen in architecture we have seen the non-volatile memory, which is the hard disk drives. It's all called as the secondary storage, and another ones like cache memory, CD-ROM, Blu-ray, magnetic tapes, and so on. So next one is this is slow enough. We have seen in the architecture diagram, right? The tertiary is slow enough. The cache primary storages are very fast, right? So it has a volatile and non-volatile, as the figure we have figured out in the next slide. So this volatile storage is simply called as memory. It's a memory unit. So non-volatile storage is called as a secondary storage, which have two things. One is mechanical and electrical. So mechanical is very less expensive, and electrical is not that much expensive, not very less expensive than a mechanical storage. So these are the things we have seen. So next is we have seen I/O structures. We have already seen the interrupts. Next one is I/O structures. We have already seen the storage structures. Now we are going to see about the I/O structures. So this is nothing but input and output operations which we are giving for the larger portion work for the operating system. So it dedicatedly manages the input of this I/O structure. We are dedicatedly working for managing an input and output because it is important for giving a reliability and performance for a system, because different systems can be accomplished and that gives different activities. That all should be managed by the operating system via a common bus. This also will do with the common bus. And this is a simple I/O structures. The thread execution have been enabled for the CPU, then the instruction execution cycle, it will move on to that. It has DMA and instruction, it will get an input and output from the instruction set. Request will be given, the data will be processed, and the interruption should be handled sequentially. So next one is architecture. So now we have seen the system organization, right? This is computer system organization. Now we are going to discuss about the computer system architecture. In this computer system architecture, we have different general purpose processors we are used. One is of single processor system, and another one is the next one is multi-process system, and the next one is cluster system. So for general discussion, A single processor system will have only single processor, right? Everything, all operations, all the interruptions will be handled by the single processor. Multiple processor will have common memory, but different processors will run by using a common memory. The two or more processors will commonly use for single memory, and the process that is called as a multi-processor. In this cluster, we are going to connect multiple devices with multiple memory. If one system, right, they are going to be separate as a manager and managing. The managing computer has failed, the manager will take whole responsibility of the individual system and it runs subsequently. It will not wait for any of the system to respond. If it is failed, the manager will take over the control and no data will be lost in it. Okay, so these are the different processors. One is a single process system and another one is multi-process system and next one is cluster system. So in there, so as all we have discussed earlier, the single process system will have a single processor containing only one CPU with single processing core. So that all the core components will execute the instruction to register and store the data locally in the same particular system. So there is a special, it also has some special purpose processors as well, like specifically processor, disk, keyboard, graphical controllers, etc. So next one is multi-processor system. So as we have discussed, it has we can combine two different processors with the common memory unit with a single core of CPU. So the processors share the computer bus and sometimes clock, memory, peripheral components also it will share and it will execute, because it's one of the primary advantage for the multi-processor system, right? Because it's mainly we are going for from a single processor to the multi-processor is only for the efficient throughput. So this is the common multi-core system. We will see the diagram for it. So first one is symmetric multiprocessing SMT. So in this we have two processors. One is of CPU 0 and CPU 1. So each and everything is have different registers and caches, but it commonly connected to one single memory, right? So this is called as SMP for a multiprocessing. So next one is dual core single chip. Dual core single chip is nothing but it also going to have different CPUs, but the cache memory is going to be shared commonly and then it will move on to the next main memory chip. So that is called as a dual core with single chip. So next one is NUMA multiprocessing, non-uniform multiple access. In this, it's going to have this what we have studied in cluster also we are going to see the same, which was interconnected with different CPUs. If one CPU got failed, other responsible or other clustered computer or clustered CPU unit will take control of the failed machine also. So because of sharing all the memory units, so each and every CPU will have the content of all the systems and processings. So next one is cluster system. So cluster system is usually used to provide a high availability of a service. We continue even if one or more system in the cluster is failed, right? So to monitor the machine fails, the monitoring machine can take ownership of its storage and restart the application whenever running is failing for one particular machine. See, the cluster can be structured asymmetrically or symmetrically. It has both symmetric and asymmetrical clustering. One machine is called as a hot standby mode, right? While the other is running on the application, right? Because that hot standby is going to monitor all the rest of the application which is running from the other systems. So this is called this hot standby host machine does nothing but monitor. It will going to monitor all the other systems. It's not going to do any of the work. Its work is mainly to monitor all other systems. So this is going to be two or more hosts are running continuously with the connection of one particular machine. See, there are different computers well interconnected, but all the systems all have the common storage that is called as the storage area network, which is SAN, storage area network. From the storage area network, in S and SAM, and it will directly communicate with the third system, and it will again start the resume the operation. Yeah. So each machine has full access to all the data in a database, which we have seen in the previous diagram. So each and every system will going to use only one common storage memory. So that is called as a SAN, which was commonly known as distributed log management, because here all the systems have an ownership for the storage memory. So if in case any of the theft may occur, so to prevent all those things, this distributed log management system is used in the clustering technology also. So because SNA has allow many systems to attach to a pool to store the data. Yeah, this all patterns have been referred from this Hilbert scats. Yeah, from this I'm going to wind up the session for introduction to operating system. So finally, thank you. If you have any doubts, you can pin it. Okay, thank you for all.